Good morning, everyone.
Morning.
Morning.
Did anybody have a fun weekend? Maybe it was so fun nobody woke up yet.
It's my dad's
Is there-
birthday, so that was fun.
Oh, it was your dad's birthday. You guys do anything? Go out to dinner or anything like that?
No, we had a nice cake, and we went biking, so that was fun. Me and my dad went biking.
That's cool. So it's actually my younger daughter's birthday today, and my older daughter's birthday on Thursday. And we have a family tradition. We always go out to the Japanese hibachi restaurant on somebody's birthday. And so as my younger daughter calls it, she likes the restaurant where they cook in your face. And so we're trying to figure out how to do that. And so you can get takeout from those places now. So we're thinking about ordering some takeout and then watching a video of somebody cooking on hibachi and then eating it. I don't know if that's going to work or not. And I don't think it's going to be exactly the same. I don't think they're going to use the little squirt bottle and squirt sake in your mouth from across the table, for example.
My family has a similar tradition, and
Yeah.
what we did is we cooked fried rice on the stove together, and then you know how at the hibachi places they throw the like zucchini at you. We did
Yep.
a zucchini launching competition.
Regularly at our dinner table, there's people throwing food at each other. So I don't know if that'll be that unique. The kids, it's the kids, right? It's not me. I've never thrown food at anybody at the table. I promise. But there is, I've mixed it up. I turned the table around today, so you get to see the other side of the kitchen today in the background. If I stop sharing, you can see it pretty well. There's over here on the counter, if I move the mic out of the way, there is some in-process cake going on.
What flavor of cake?
It's chocolate cake. It's gonna be 4 layers. It'll be a cube when it's finished, and it will be the shape of a Minecraft grass and dirt block. And then I'm assuming somebody's gonna smash it and it's gonna explode, because that's all I ever see when the kids play Minecraft. But so having a Minecraft themed birthday today. Looks like everybody's getting online. Does anybody know what we're going to talk about today?
Functional design.
Good. I'm glad somebody paid attention to what was on the screen when you all logged on. I'll get that back up there. So can somebody tell me what functional design means to them?
Having a design that serves a purpose.
So a design that serves a purpose. Okay.
Something that works and is durable.
So it works and it's durable. Okay, so I've got purpose, I've got works and durable. Does anybody else have sort of I guess if we're gonna define a phrase like functional design, maybe we should make sure that we can understand and define both words independently. And so functional, I think, means it works, right? And so that was the first thing that came up. So something that works, something that's durable. My camera seems to be turning off. I don't know. Oh, you know what? I don't think it's using the camera. Yeah, my camera definitely turned off. I don't know why that's not supposed to time out. It's supposed to stay on forever as long as it's plugged into the power. But so functional design. So functional means that it works. and maybe that it's durable. If something needs to work over a long period of time, it needs to be durable. Does functional mean anything else to us? No. Okay. So functional basically means that it works, and that we have something. Now, what's a design?
A drawing or layout of something.
It could be a drawing or a layout. What else is a design?
An
An
idea.
An idea. You certainly need to have an idea before you can have a design. Is there anything else that makes us think of design?
An implementable idea.
An implementable idea.
A plan or set of
So
instructions.
I've got some examples of some things that were presumably designed. Let's see if the author deleted this story. I totally should have clicked on the link before thinking I was going to show it to you guys. That's a bummer. It was really funny. It was a bunch of non-functional designs. So things like stairs that went to blank walls, and a lot of really fun things that we could laugh about to get the laughter up here. Okay, you know what I'll do? I will find the part of me showing that in a previous recorded video, and I will send you the YouTube link to that thing if you want to see the really funny things about designs. So functional design can go wrong, right? So if we design something that doesn't do what we want it to, then it's definitely a failed design. So functional means that it works. The design is so somebody said the idea, and before you can have a design, you have to have the idea. But I would say the design is the designer's representation of the idea. It's the way that we as designers, so for most of the class, I say we're wearing the hat of manufacturing engineer. And today we're going to flip back and forth between manufacturing engineer and design engineer. And I do that because a lot of you will be in that position as you're going through your careers. You'll be either you'll be designing things that need to be manufactured, or you'll be working on manufacturing things that other people have designed. This communication between design and manufacturing is going to be really critical in your careers as you go forward. So if we look as a designer, we start with an idea, with a concept. And then our design has to convey enough information to the manufacturer, to whoever is going to make it, so that they can make the thing that we wanted. Does that make sense to everybody? So as the designer, we have to decide what it is we want, and then we have to make sure we convey that information to the people that are going to be making it. So to do that, all right. So what does it mean to design then? It's to, because in industry, people talk about, so there's the design of this advertising media right here that we're showing on the screen. So is that truly design? Do we design this ad for whatever it is, some kind of sunscreen or face lotion or something? So do we design that?
Yeah.
So in is it the same as engineering design?
I think it's more designed to like create a response, if anything.
So if you go to what's the famous school in Rhode Island? RISD, right? Rhode Island School of Design. This seems like there should be another letter. Have you guys heard of the Rhode Island School of Design? Or there's some real famous designs. RISD rejected you. Well, you got into a better school anyway. But what does RISD stand for? Rhode Island School of Design. Oh, yeah, perfect. I got it. All right. So do they teach the same kind of design there that we teach at WPI?
Oh,
I actually don't know that. I don't know that much about the school, but when we talk about design at WPI, so who's taking a design class here? Some class that has design in the title of the class. You could actually answer that question in the participants thing. Say yes if you've taken a class that had design in the title of the class. So 7, a couple of no's, 8, yeah, 10. So Adam, you said yes. What design class did you take?
ES 1310.
ES 1310. And what was the focus of ES 1310?
CAD modeling and designing like the parts.
Okay. Was it focused on designing the parts or on modeling the parts?
More modeling.
Okay, that's what I thought. I took ES 1310 in 1989. And in 1989, when we took ES 1310, we had to make sure that we rolled the barrel of the pencil in our fingers so that the line thickness would stay the same as you went across the page. So when I took ES 1310, we were designing, and it was about how do you represent the design. It wasn't about how do you create the design. And I think that theme has stayed. Did anybody, so I'll clear the responses. Did anybody take a design class at WPI that has design in the title, but wasn't ES 1310? I got a yes somewhere. This is sort of like, Jake, what class was that? Oh, he's trying to find the unmute button. All right, Madeline, what class was it that wasn't ES 1310?
Jake wrote it in the chat.
Oh, Jake wrote in the chat. Advanced computer aided design. And so Jake, in advanced, sorry, somebody spells just as bad as me in spelling design just above Jake's chat. Advanced computer aided design. And so Jake, was that the same theme as ES 1310? You can write it in the chat or you can shout out, unmute. I think it is. Or anybody that's taken it, you can just shout out. Similar theme, more focused on kinematics and simulation. Okay, yeah. And there's a couple others. There's design of machine elements. There's some other courses that we teach at WPI, but what we're and I there's got to be a CS major in the class, maybe, I don't know, but I know there's classes about designing software, or object-oriented analysis and design, exactly, object-oriented design concepts. So yeah, there's
yeah, I'm also a CS major, but I took a class that's all about UI design called human-computer interaction, which obviously doesn't have a design.
And is that, I would say it totally is design. And I'm gonna try to close the loop on this shortly. But is that class actually offered by the School of Business or the CS class? I think it's cross-listed.
It's the CS courses.
Okay, I think it may be cross-listed or there's a similar business school class. So in all of these types of design, whether we're designing an ad to sell our sunscreen, we're designing a bridge to get across a river. By the way, have you guys heard the story of the Tacoma Narrows Bridge?
No.
Yeah.
I know this is not a civil engineering class. Somebody said yes. Can you explain what happened to the Tacoma Narrows Bridge?
That was the one that the wind matched up with like the resonant frequency of the bridge, and it like,
Yeah, the wind blowing by the support cables caused the cables to vibrate at the resonant frequency of the bridge, and the bridge fell down. It was a giant bridge across the ocean and near Seattle in Tacoma, Washington. It stood for many years, but eventually the fatigue loading from this vibration, or it stood for some period of time. I don't know how long. It's pretty catastrophic when a bridge spanning part of the ocean that connects two major cities falls down, you would say, right? Does anybody know that the Tacoma Narrows Bridge was designed by a WPI graduate?
The one that fell over or the new one?
The one that fell down.
Let's go. WPI represent.
He was actually the last person on the bridge also. I mean, they knew it was going to fall down. They knew it was problems. So it wasn't like there was people driving on it when it collapsed. But he was trying to figure out what was wrong. And he was standing on the bridge when he realized that, oh my God, this time it's going to go down. And he ran off the end of the bridge, which is kind of interesting. So there's this design. So whether we're designing a bridge, we're designing a branding campaign, it's all the same kind of design. There's different tools that we use to analyze it and to determine if it's correct. It's when we're designing, what we really want to know is what do we need to achieve? Somebody posted a link. Is this a link about the Tacoma Narrows Bridge? It's pretty dangerous for me to open a YouTube link.
A link of the bridge, don't worry.
I'll open it on the screen that's not shared. Yeah, we won't watch the whole 5 minutes, but there's got to be some good. Yeah, check this out. So this is just the wind blowing on the bridge.
Oh, geez.
Whoopsie. But it's a pretty massive structure to have just fall down.
I think I saw that right at Six Flags.
They should have a ride like that at Six Flags if they don't. Oh, man. I have a season's pass for Six Flags right now. Can't go there, though. It's closed. I wonder if I can get my money back. You just reminded me. We were going to do a Disney trip this year. I hope that there's some chance it'll happen. Let's see. All right. So let's get off the screen. So whatever it is you're designing, you've got to think about what is it that design needs to fulfill. And then how could I fulfill that? Oop, the YouTube's still playing. So I would say that all these types of design are the same. And so the first thing to understand is what do I need? What are the customer needs, if we could call it that? So if you and it's easy for us to visualize it in mechanical design things, because we as engineers and engineering students, we tend to think about these kind of mechanical solutions to things, or the CS solutions to things. So whether you're designing the user interface or the widget that's going to hold up the standing desk, you've got to think, what is the customer need? So what is it? So you have to identify who the customer is. If we know who the customer is, we can say, what does the customer need this design to fulfill? And sometimes you get that information by surveying the customer, by talking to them, but you get a list of all the things that the customer needs. And then a really good design technique is to take those needs as expressed by the customer and translate them into engineering speak. And so when we do that, if we translate, I'm looking for, yeah, this is the one I'm looking for. If we translate them into engineering speak, we get the right technology. Oh, you guys can't hear it, can you? Hold on. Let me fix the screen sharing. More. Share. Stop live streaming. Copy live streaming. Share computer sound.
It's also muted.
And yeah, I got that too. I knew I had to fix both. Come on, little slide thing, go away. You guys see the little thing pop up, right?
Yeah.
Yeah.
That's pretty funny. I can unmute it, drag it back on the screen, and see if I have possibly the right slide. Okay. So much for my PowerPoint skills here. And now is there no sound?
The YouTube video is muted.
It remuted when you left the slide.
Amazing. Wait. I have presenter view open. Maybe I can fix it on my other screen. No. I know. I can loop. This is way easier in the classroom.
You can also just hit M on your keyboard to unmute the video while it's playing.
Oh, really? That's cool.
In the tech is you
Look at
take
that.
the specifications from the
Hey, thank you. I
customers
learned something today.
and you bring them down to the software engineers.
Yes, that's right. Well, then I just have to ask.
So he takes the customer needs, right? He gets the customer needs and he brings them to the engineers.
Software people, huh? Well, I'll tell you why. Because engineers are not good at dealing with customers.
So
wait, is that true?
Hopefully not.
Depends on the person.
From what I've heard from many of my graduated friends, it is 100% true.
You think so? So I don't know. Do you know how you can tell the extroverted engineer?
How?
Oh.
They look at your shoes when they talk to you.
Ah.
All right, so let's finish up this clip though.
You physically take the specs from the customer? Well, no, my secretary does that, or they're faxed.
So then you must physically bring them to the software people.
Well, no. Yeah, I mean, sometimes.
What would you say you do here?
Well, look, I already told you. I deal with the goddamn customers so the engineers don't have to. I have people skills. I am good at dealing with people. Can't you understand that? What the hell is wrong with you people?
What you do.
All right, so so we've got to understand what it is the customers need, and then we got to translate the needs of the customers into what we call functional requirements. So these are functions that the thing we're designing has to fulfill in order for it to be a successful design. And so it's good to have people that have people skills when we're doing this process. It's good to be able to interact with the customer. Let's think of something that we could design. So something we all have in our house. So everybody's got a kitchen faucet or a bathroom faucet in their house, right?
Yeah.
So everybody has some way to make water come out of a pipe and come at your hands. Let's say the customer need is to wash our hands because we should be washing our hands lately. Or these days. We always should have been washing our hands, but it's really important now. Okay, so if we're the customer and our desire is to have some means to get water on our hands, what are our customer needs for developing this? I'm going to try a new thing here. I'm going to try to share, new share. Whiteboard. Let's see how that works. All right. Do you guys see a blank piece of paper now?
Yeah.
Sweet. All right. So what is it that what are the customer needs for our hand washing station?
You need water.
A
Need
sink.
water.
Clean water.
This is hard to write on this way. Maybe there's a text thing.
So
Oh, there's text. All right, totally cool. So we need water.
Soap.
We need soap.
a sink.
What's a sink?
A vessel for delivering water controlled to your hands.
And a drain.
So we need to, so, all right, so we need so when you said we need a sink, you were jumping to a solution. But the need is to control the location of water.
So you need a spigot.
So
Faucet.
all right, but I'm gonna leave sink for now. Is it?
Some
I
way
think
to
I spelled
dry.
faucet. You
need a place for the water to go.
We waste.
Oh, clean water, not just any.
Well, we want clean water in.
Also, probably not
Do we?
hot or super duper cold water, a temperature that.
So we'd like to control. In fact, at different times we might want different water temperatures, right? So all right, so we've got water, we've got a way to make the water flow. Now we could just have water in a bucket, right? And we could have some soap next to the bucket, and we could dip our hands in the bucket, lather up the soap, dip our hands back in the bucket. That could be a solution for washing our hands. What's the problem with that solution?
It's not really long term.
You're washing your hands in contaminated water.
You don't have clean
Right.
water.
After the first time you dip your hands in the water, you've contaminated the water. Okay, so we've got water, soap, sink. All right, so this is why we want the water to flow. We don't want it to go on the floor, so we've got this sink or something to
Basin.
Maybe a drain.
and that has a drain in it. So we've got some idea here. Let's focus on water in, so water flowing in, and control water temperature. And so that's usually done by something we call a faucet, right? So if we're gonna design a faucet, I'm gonna go ahead and erase my attempt to write with my finger. Okay. So if we're going to design a faucet, what we need to control water flow rate. Is that true?
Yeah.
All right. And we need to control.
Well, technically, you only need like a way to turn the water on and off. You don't really need different amounts
All
of
right.
water to flow.
All right. So
To be able to
we
make the water
only
flow.
make water stop, make water go. All right, we want to make water stop. We want to make water go. Does anybody want to control how fast it goes?
To an extent, like maybe if we had a set rate, we wouldn't want it to just drip out.
Right. I think it's.
Does the intensity of the flow rate affect like the temperature? Because isn't it the more like the higher the higher you turn the hot side, the hotter it gets, right? I've only used things that do both.
I actually had a faucet in my house when I moved in where there was a sink and there was a hot water faucet and a cold water faucet. And the only way you could control the temperature was by letting the water mix together in the sink. Does anybody live in a house or ever lived in a house where that was the setup?
They're extremely common in Britain, and they're awful.
What makes them awful?
It's because, like, say you're in like a public restroom, right? You wouldn't have the ability to clog the sink to control the temperature. So you have to kind of shift your hands back and forth between the two, try to equalize the temperature.
Or you have to carry around one of those little stopper things, right?
Mm-hmm.
All right, I'm going to see if I can change the share to be Faucets Direct's website. Okay. So here's some examples from Faucets Direct, right? And so here's a pretty common bathroom sink. I'm assuming this is going to open up and show a picture when I click on it. Maybe. Well, that wasn't what I meant to do. Bathroom faucets. There we go. You can tell I've rehearsed this part of the lecture. All right, so we've got this pretty common style here, though, right? Where we've got two handles, one for hot, one for cold. The water comes out. Now, why do we have a hot and a cold, and then the water comes out the center for these faucet designs?
So you can have two inputs and a mixing chamber before you get to the
Right.
output.
Because in the typical American home, at least, we have some way of making hot water and piping it to wherever we want to use water in the house, right? So there's a mixing valve that mixes water of some temperature with water of some other temperature. And you control that by either opening the cold valve more or the hot valve more. But every time you adjust the position of either the hot or the cold, you change the flow rate of the water that comes out, right? And we've all, especially in a shallow bathroom sink, we've all experienced turning one of these handles, having the water splash out and get all over us, right? And so is this a good design?
I mean,
Not if
it's
it
worked for a
splashes.
while.
But is it a good design? Is it the faucet design you would want to have in your house?
Yes.
Really? What if you could
Not
have
if
a
it splashes.
faucet? What if you could have a faucet that controlled the temperature independently from controlling flow rate?
Meh.
Meh. Just not
It
into it.
doesn't really make that much of a difference because you're always going to want to have, well, not always, but like you're never going to need super hot water at the same time. You're going to need like a lot of water. If you need like a little bit of water, you're not going to really care about the temperature.
This is actually pretty cool because nobody's ever argued this point with me. Oh, good. Go ahead and tell me why you disagree.
Say you've got like a kitchen sink or something and you want really hot water because you're trying to make tea or you're trying to boil water. And sometimes your kitchen sink gets you water that's slightly hot enough to put in a tea bag and you want it quick. So you turn it on and turn it off and you get super hot water really quick and then you can make a tea.
Huh.
Well,
Some houses have the instant hot thing.
Why don't you just turn the water on till it's really hot and then you stick the thing under and pull it out really quick?
Wasting water.
So these are solutions that get around the fact that we don't have independent control of the flow rate and the temperature. So if you could set a temperature and then you could set a flow rate, and I recently bought a shower valve that does this. So it's actually got a digital readout. I can set the temperature that I want, and then with the handle, I can say how much velocity I want to come out of the either the tub spigot or the shower. So the ability to control these things independently gives you more flexibility.
I also have a shower at my house that does that, but I also have never touched the pressure. I just put it on like the max pressure and I only touch the temperature.
Okay. Clearly, which, you know what? If you go to the faucet aisle, they still sell a lot of these independent mixing valve faucets. So clearly there's a market for both. I would argue that the better design is the one where you have independent control, just in case you need one. But we can get off that. But the whole idea there is to understand the customer's needs, figure out the functions that it needs to do, and then specify design parameters that will allow you to fulfill those functions. if we go through that. I'm going to go back, I think, to the presentation to try to get back on course here. I guess we're not too far off schedule. So, oops, I didn't mean to stop the share. I want to share this one. All right. So the next question is, once we've figured out our concept, we've gathered our customer needs, we've figured out what functions in engineering speak that we need our design to have, we have to represent the design. And so in the people that took ES 1310, did you spend a lot of time making 3-view drawings?
Yes.
Yep.
Yeah.
You did. What's the purpose of a 3-view drawing? For this, I guess this is 3 views plus a
You
projection,
see all
right?
the sides of the part, so you know what it looks like from all angles.
Okay. Why is it better or different from simply having the solid model and being able to rotate the solid model around?
At the same time, see all the things at the same time.
It's more
Okay, so you can
convenient if you don't have a computer, it's more convenient to just have the printout. Like if you're going to machine the part.
Absolutely. If you didn't have a computer, you would actually have to have a physical model of the part instead of a computer rendering of it. I would say though that it's you guys have taken some solid models and created toolpaths for them in the CAM software, right? And so was there ever things that you needed to know a dimension for in order to make your life easier as the programmer?
Yeah.
Yeah. And so if you have the solid model, it's easy to bring the solid model into the CAM software and to use that to visualize what's going on, to even set the chain features or pick the features that you're going to manufacture. But when you're controlling the options for the cutting operations, it's nice to be able to look at the drawing and quickly know what some of the dimensions are so that you can quickly type in those numbers instead of having to calculate them or figure them out on the solid model. Is that right? Does that make a lot of sense?
Mm-hmm.
So I would say the ideal sort of for this kind of a mechanical part, ideally what you want to be able to give the manufacturer is a solid model of the part you want that's accurately drawn, and then a correctly dimensioned and toleranced, because what's hard to convey in a solid model, at least hard to convey visually in a solid model, is what are the tolerances that we're willing to accept on these measurements. Now, if we, I wonder, can I zoom in on this? Oop, back. Control +++. Nope, that doesn't zoom in. Does zoom let me zoom in? Select, save. No, zoom doesn't let me zoom in either. So on all of these parts here, though, we see, so this is 3.000 inches. What does that mean to somebody that had ES 1310? Why isn't it just 3 inches with no decimal place?
That's the amount of variance you're allowed to have.
So somewhere down here, there'll be a tolerance block that says, and if you could zoom in enough, you would see that it says for 3 decimal places, the tolerance is 0.005 inches. So plus or minus 0.005 inches. So we're allowing that dimension to vary by 10 thousandths of an inch, or 0.01 inches. And we're shooting for the middle. 3 is in the middle, and we're allowing that to vary. Now, is that a good tolerance or a bad tolerance? I mean, it's the one on the drawing.
Like this.
It gets the job done for the customer.
So it's well,
presumably
it's what the customer told us. We don't actually know at this point if it gets the job done for the customer, but the customer told us this. So Cole says it depends on the application. And so as our first glance at this, now you guys have one of these Y blocks, right?
Yeah.
Yeah. So what's the function of that dimension? Just that outside dimension on the Y block. What does it do?
Always the health and safety of our patients, employees, and the communities we serve. While Cliff now processes
Is that mine or is that somebody else's?
Someone else's.
Okay.
Is that the answer?
No, it's not, but we should.
Guarantees the health and safety of our clients and customers.
Yeah. It might be that I have a YouTube video playing in the background, but I don't think so.
It's
Sounds like somebody's microphone. I'm gonna go to people. If I get back to participants, it is. We'll go ahead and mute that one. Fixed. So what does that dimension do?
The 3?
Yeah.
It's the length of the top face of the part, and it like
Right.
affects probably the whole spacing is being affected by it too.
Well, if that dimension was 4 inches, would the engine still function?
Yes.
Right. So if it was 2 inches, would the engine still function?
No.
Right.
Not with the
And
other-
because if assuming that the datum is in the center at least, right? Well, I guess no matter where you put the datum, if it was 2 inches, you wouldn't be able to put the screws in for the clamp that holds the cylinder to the Y block, right?
Yep.
Right. So that dimension, that 3-inch dimension, is really it's visual. We'd like it to be about the same width as the base underneath. It makes us feel better if it's the same width as the base underneath. The base is nominally 3 inches wide. It's actually a little bit under 3 inches. So we have that Y block at 3 inches. Is that correct? Yeah. And so the this dimension here, the spacing of the holes, though, is that a functional dimension?
Yes.
Yes. See when I wiggle my mouse there? And so that has to be something particular because the clamp that we're purchasing has a particular spacing, right?
Yes.
And so how much uncertainty can we accept here? Now, it's got the same tolerance. It's plus or minus 5/10 or 5 thou rather. So it's plus or minus 5 thousandths. Did we talk about the techno babble in machine shops, the jargon that we use? So if I say it's 1/10, what do I mean? If I say it's a tenth, I mean it's 1/10 of 1,000th of an inch. So I mean it's 1/10,000th of an inch. If it's 0.01 inches, that's 10 thousandths. If it's 0.1 inches, that's 100 thousandths. And it's just the way machinists talk to each other. If when you get to the machine shop, if you don't use the terms that way, they're going to believe you don't understand anything that you're talking about. And at that moment, their favorite thing to do is to make you exactly what you asked for, especially if they know it won't work. So we how do we figure out the tolerance for the distance between those two holes is an important question that we're going to ask ourselves when we're doing our functional design. So, so how do you figure out what the right tolerance is for the spacing between those two holes? What do you have to know in order to figure that out? Are we still here?
Yeah.
So what do we have to know in order to figure out the correct tolerance for the spacing between those two holes? So I put a tolerance here. I put 5 thou, plus or minus 5 thou, so 10 thou is the tolerance. But what impacts picking that tolerance? We're purchasing the clamps. So what happens if we put the holes too close together or too far apart?
You can't screw through the holes and attach the clamp.
Right. If you put the clamp down on one side, you put the screw in it, you won't be able to put the other screw in. Is that correct?
Yeah.
And click yes or no on the poll thing if that has ever affected you in your life. If you've been trying to assemble something and the holes didn't all line up.
I hate IKEA.
Now, does it? Yeah, IKEA doesn't get that wrong. I've never had an IKEA.
I've had it go wrong with IKEA. I have.
Wow, you're unlucky. I've never had a problem. Hey, did you hear that IKEA has released the recipe for their Swedish meatballs?
I did.
So that you can make them at home. We're gonna do that this week. My kids love the IKEA meatballs. I like my mother's Swedish meatball recipe, but the kids like the IKEA meatballs better. So I don't know.
Chipotle released its guac recipe.
Wow. I'm gonna have to go to the. I'm sure to make the IKEA meatballs, I'm gonna have to go to the garage and get some sawdust to mix in with the ground beef. But
oh, of course.
Oh wait, did I say that out loud?
Sawdust.
That's fiber. You need fiber.
Yeah, you need cellulose in your body.
There you go. Even though you can't break it down, but it's fine.
I won't use the sawdust from the old pressure treated lumber with the arsenic in it, though.
I'd hope not.
Okay. Are you working on frosting the cake? Okay. So Michelle's assembling and frosting the cake over there in the background. Have you guys met Michelle yet?
No.
Okay, she doesn't want it. She doesn't want to meet you guys, so she's just making the cake.
Ouch.
So what is it that we have to understand in order to know what the right spacing for the holes is?
The hardware you're using?
All right, so we have to know something about the hardware we're using. What do we have to know about the hardware we're using?
Its size.
So what about the size?
Diameter.
So all right, so you're saying we need to know the diameter of the hole in the hardware. What else do we need to know about the hardware?
The feeds and speeds.
No, we don't need to know any of that. Because we're not actually making the hardware, but we need to know the diameter of the hole that goes through the clamp, and we need to know the spacing between the holes, right? And so if we know the spacing between the holes and the diameter of the hole, now, what should so if the diameter of the hole is exactly the same as the outside diameter of the fastener that goes through the hole. So let's say that the diameter of the hole is the same number as the diameter of the fastener that goes through the hole. How much uncertainty can we have in the placement of the holes?
None.
None. So we need the hole that we're going through to put the fasteners through to be larger than the diameter of the fastener. How much larger can that hole be?
Well, you need the threads to lock. So, however, I guess.
Well, so the threads don't interact with the clamp. The threads only interact with the Y block. So it's a clearance hole in the top of the clamp. So how much larger than the diameter of the threads can the hole be?
Has to be less than the head of the screw that you're going to use to screw in.
It has to be less than the diameter of the head of the screw. And if it's close to the diameter of the head of the screw, when you're tightening the screw, you're going to actually machine the clamp, and you're going to broach your way right through the clamp with the screw head. So it's also going to depend on the strength of the material, on how much bigger it can be. But there's a optimal or ideal or best size for the hole being larger than the threads on the fastener. And then our uncertainty in the placement of the two tapped holes that we make has got it, the distance between them has got to be less than, what is it? Less than half of the, or the uncertainty in the distance between them has got to be such that if you have one screw in and it's all the way up against the hole, you can fit the other screw in. Is that correct?
Yes.
And so if you wanted to put a functional tolerance on this drawing, how would you know what that number was? What would you have to do? So I guarantee you, we picked this tolerance out of space. We didn't make it a functional tolerance. But if we wanted our tolerance to be the right number and not just a number that might work, what would we do?
Ask our customer.
Well, we are the customer now. We're the designer. So to put the correct tolerance on the drawing, that's the designer's job. It's not the manufacturer's job. So
probably experiment.
Because what the customer wants is for the cylinder to stay attached to the Y block. The customer doesn't care how we did that. We chose to use this clamp. So somebody said we could do an experiment, right? So if the people we're buying the clamps from can't tell us what the uncertainty in the placement of those holes, because there's going to be uncertainty in the placement of the holes on the clamp too. So if they can't give us that information, we're going to have to buy a bunch of clamps and measure them. And we're going to have to then decide. And that's actually how we figured out what the diameter for the O-ring grooves was for your cylinders, is we bought a bunch of test tubes and we measured them because they're not all the same. And we actually adjust that based on the batch of test tubes every year when we buy new test tubes. So sometimes you have to do an experiment to find out what's the right tolerance. Sometimes you can go look it up in a reference manual. And on Thursday, we're going to spend some time talking about how to find the correct tolerances by looking them up in a reference manual. And also between now and Thursday, I guess that would be Wednesday. On Wednesday, I put in the ME1800 this week to watch. It's about a 45-minute video. And it's a really good introduction to what we call GD&T, so geometric dimensioning and tolerancing. And he talks about the way to correctly display your tolerances and your desired numbers, and they go into things like flatness and things like that. Tells you how to correctly represent that on the drawing so that when you as a designer send the drawing to the manufacturing engineer, you'll get back the thing that you wanted. So I'd like you guys to watch that video tomorrow. On Thursday, you don't have to wait until tomorrow. You can watch it today. On Thursday, we're going to talk about looking up the correct numbers, and we're going to also to close that discussion about GD&T. So I'm going to push back the due date another week for that group assignment because I didn't get all the details put together and posted for you. There was nominally going to be a third group assignment. I'm going to cancel the third group assignment. We'll talk about that in discussion instead. So I think, let me just double check to make sure there's nothing missing on Canvas right now.
I have a question, Professor.
Yeah.
So the quiz wasn't multiple attempts. Is that the case for the next?
No, it was supposed to be multiple attempts, and I did fix it on Monday. I got an email from somebody that told me. So if you want to go back and do that, I won't. Anybody that does the quiz that was just due again, I won't mark that late.
Okay, thank you.
So if you just if you want to keep working on that, that was my screw up when on the assignment. So I'm going to push the due date for this back until the end of next week, so that we can get you more details about how I want to do that. I'd rather do this one well than add a third one. The week 5 quiz we'll go through it Thursday morning to make sure that it's got all the good questions. That'll be doing it next week. And
Wait, when is the week 5 quiz due?
at the beginning of next week. They normally do on like the Monday at midnight. So we'll go through it on Thursday in class to make sure that it's all correct, and then have that for Monday next week. I think Wednesday's the video. We're starting with turning in Esprit this week. Some of you guys have already started that. And what I would like you to do with the Stirling engine assembly and testing, and maybe you've already assembled it, but you know that we got 3 different pistons there, right? They should be 3 different sizes. And what I'd like you to do is to figure out which of those pistons works better in your engine. And there should be one that works better in the engine. Somebody's having machinery's handbook stuff. Yeah. So it doesn't matter if you're using the same version. The section won't be any different. And to get to the machinery's handbook, you do have to go to the library website first. Then it may ask you to log in with your WPI credentials, and then you should have access to it. If that's not working, then reach out to the WPI help desk or the library staff, because that should always work no matter where you are. Yeah, so I think we're good. I think we're pretty good for this week. So what I'd like you to do is to experiment with the different pistons, feel the different fits of how the piston slides and fits in the cylinder, and to determine, if you can, which one operates better for your engine. Is it many people having trouble accessing the machiner's handbook, or just a couple?
I couldn't figure it out either.
Has anyone been able to access the machinery's handbook?
I was able to.
I was able to.
Okay, so if you're having trouble, then reach out to either the library or the ATC, and they should be able to help you figure out what your connection is.
I might have just had the process wrong, so could you just kind of do it real quick on the screen sharing, just so I can see it?
Yeah. I think there's something wrong with the cake decorating.
She stormed out of there really quickly.
Yeah. I heard just before that this isn't working.
Oh, that's unfortunate.
Yeah, I think this is the 28th edition. This is available. You want to find one this is available online. And so this one says available online. And so it's, I think, sending me, I think it remembers this computer because I've already logged in through the proxy. But let's see what's going on. Yeah. It remembers this computer. So it just logged on. But at that step right there, it should bring you to a proxy server to log on with your WPI credentials if it doesn't know you already.
All right, that was good.
But yeah, and then we'll come down here, and I think we're looking at speeds now, right? Next week or on Thursday, we're going to be looking at this gauging, dimensioning, metrology, and measurement. So find it. Math, strength of materials, tool making, manufacturing processes. I think I scrolled past it. Is there a search up here at the top? Search within, yeah. Probably should have had more words than just power. How about feed speed power? Estimating speeds and power. So you want section, in this version, you want section 44.8. And you probably don't want to have it show everything. All right, so yeah, this is where you'll find the section. For the drilling power question, you may have to go back and look at a table previous to that page. But it'll tell you in the example what tables you need to look at, and you should be able to find those tables. Anything else? Okay, so I will see you guys on Thursday then. And have a happy birthday for everybody whose birthday it might be, or soon will be, or was. And I'm going to see if I can help fix the cake.
Good luck.
Yeah.